say that it is. And then we have to reverse its digits. So we get 263, and then we add them. So then I'll guess what you've got, what the answer you've got. Okay, so let me, so you can take any other 3-digit number. Take any 3-digit number with distinct digits and reverse its digits and then subtract the two numbers, and then whatever the result you got, reverse it and then add them. Okay, so you can raise your hand. You can raise your hand when you're done. Okay, so Saite, can you unmute someone?
All right, let's see. Jayashree.
If you take any 3-digit number, then it always...
Don't
tell the answer.
Don't tell the answer, but I will guess it. So the second digit of that number is 0. Am I right? Am I right? Jayashree?
No, it comes to 999.
Can you check your calculations again?
Okay.
Okay. Can you unmute someone else, I think?
Avnish.
Yeah. Yeah. So now if we add all the digits of your answer, you will get 18. Am I right?
Is that correct, Avnish?
Then can you please check your answer again?
Oh, Jayashree is saying yes. Wow. Let's see. Divij. Can you guess Divij's number, Swasti?
Yes.
Okay. The number
Which
is odd. Don't tell me the answer. Just tell me if your number is odd or not. Is it odd? Divij,
no.
is your answer odd?
No.
Can you please check your calculations again?
I didn't get the answer. I guessed 298 as 3-digit number, but I didn't got the answer.
Okay.
So can you do it for 298 and show Divij, Swasti?
Okay. So 892 minus 298 is 594. And then when you reverse, you get 4 95. And then when we add, we get 1, 0, 8, 9. Is it the number you got? Everyone got?
Yes.
Wow! Do you think there is a magic?
Yes.
Let us try one more 3-digit number. Which number do you want to take?
892.
892. No, we did for that, right? So
Yes.
tell me another number.
240.
Okay. So now 240 minus 42 is 198. And then
Yes.
198 plus 891 is again 1089.
Yes.
Wow. So what do you think? Is there any number like 1089 for 2-digit numbers?
Swasti, a few people have doubts. Do you want to take them right now?
Okay, sure.
Okay, so if you have a doubt, then raise your hand or else lower your hand. Okay, Kashyap, what is your doubt?
Ma'am, my doubt is I have tried this number 738. So if I reverse it, it is 837. Where's the pen now? If I reverse,
helping you
if I reverse it, it is 837.
So
So-
let us work it out with her. She's working
Okay,
it out.
so 7 minus 8 is, yes, 99.
Yes. So now we have to add 10 to the left. If we get a 2-digit number.
Oh,
So when we reverse, we get 990, and then we get again 1089. That's a very nice doubt question.
thank you.
Thank you.
Okay.
There are a
Second-
few more doubts. Sai Arun Prasad Sundar.
I mistakenly forgot to lower my hand, but I have a question. That yes, but I found out for 2-digit numbers that it comes like this. How is it happening is something I don't know. But why is it
Wow.
happening? That's what I don't know. I found it in a few numbers. Yes, but there's one startling thing. All the time it's coming nearly 891.
Oh, looks like someone figured it out. You can do it too.
That
You can do
something
it.
is related to 891, 792, 693, 594, 495, 396, these numbers. It's
Wow.
coming all the time, those numbers. And when we reverse them and add them up, it always comes to 1089. I think that's what is coming in this plot.
Wow. Okay, let's move on to the other doubts. Mayuk.
My doubt is, will this method work for palindrome numbers?
You can check it out on your own.
It seems like we're getting a lot of raised hands. Let's wait for the end, and should we take the doubts at the end?
Okay, sure.
Okay, let's move on with the next magic.
Okay. So So do you think there is a number like 1089 for 2-digit numbers? Let's see. Yeah. So which number do you want to take? Okay. Someone is saying 99. Let's take 42. 42 minus 24 is what? 18. And 18 plus 81 is 99. Okay. Let's take another number. Which number do you want to take? Okay, 66. But we needed to have distinct digits. So let's take 74. 74 minus 47 is 27. And 27 plus 72, we again get 99. Wow. Okay. Can you try to prove for 99 and 1089? You can take it as a homework. And I also have one more question to explore. Do you think there is a pattern in 99, 1089 and so on? Okay. Someone is saying both are multiples of 99. Okay. So let's learn another interesting property of a number.
Just a second, Swasti. Do you want to take doubts? So if you guys have any doubts, we will take them now. You can raise your hand if you have a doubt.
Yeah, okay, sure.
Okay. Anuj?
I wanted to ask, why doesn't it happen with the 99 number or 999 number?
Because they have distinct digits and that does not fit in our rules, right?
Okay.
And you can try it out. You can try to prove it. I mean, not prove it, but try to do it for not distinct digits.
Okay.
Okay.
Thank
Any
you.
more doubts? Yeah.
Okay, no more doubts, I think.
Okay. So let's move on. Let's see another interesting property of a number. So we have to take any 4-digit number. So Saiti, can you unmute someone? You don't need to raise hand.
Okay, I'm just going to unmute anyone at random, and then you have to tell us a 4-digit number. Hiren, be ready because you might get unmuted. Be ready with a 4-digit number.
Am I audible?
Yes,
Hello.
you are.
1645.
Yes. Okay, Vedant says 1645. Who else was saying?
2332.
2332.
Okay. So let's take 6, 8, 9, 7. So now we need to arrange this number in ascending and descending order. Not this number, but this number's digits. So 9, we get descending order is 9, 8, 7, 6. And then if we arrange it in ascending order, we get 6, 7, 8, 9. Now we subtract these two numbers. And what do we get? We get 3, 0, 8, 7. Am I right? Okay.
Yes.
Yeah. Okay. So now we arrange. Now we do this process again to 3087, and before in the previous method we did we reversed the number, but here we are arranging its digits in ascending and descending order. So 8730 minus 378 is what is it? It is 7 3 5 and 2. 7352.
8352.
Yeah. Sorry. Yeah, right. It is 8352. So now we do the same process to 8352. 8 5 3 2 minus 2 3 5 8. So wait, what is it? Okay. Someone is saying it is 6174. Yes, that's right. So now we do the same thing to 6174. 7 6 4 1 minus 1 4 6 7 is 6 1 7 4. Wow, we got the same number again. So what will we get after this step? We will get 6174 again and again and again. Wow, this is interesting, right?
So any 4 digit you add, it will be always 7 digit. It will always end to either 2 or 3 or 4 step. It will always go to 6274.
Okay, who was it?
Yes, yes, exactly.
Yeah, yeah. It's a.
Yeah. So, do you want to check for another 4-digit number? Let's see. Who wants to tell another 4-digit number? Okay. Yes. Can you unmute someone, Saite? Vedanta, Sai, Arun, Prasad.
Yes, sir. It is 9352.
9352. Okay. So 9, 5, 3, 2 is the descending order, and ascending order is 2, 3, 5, 9. And the subtraction is 7, 1, 3. Sorry, 7 and 3. So now 7, 7, 3, 1 minus 1, 3, 7, 7 is 6, 3, 5, 4. Okay. So 6, 4, 6, 5, 4, 3, minus 3, 4, 5, 6 is 3. 0, 9, 8, and 7. Okay. So 8730 minus 0378 is 8, 4. No, it's not 4. It is 3. 8, 3. 7, 5. Sorry, 5. And 2. So 8, 5, 3, 2 minus 2, 3, 5, 8 is 6, 1, 8, 7, and 4. So we got 6174. And then again we will get 6174. And again 6174. Again 6174. And so on. Wow. And this is called as Kaprekar constant. This number 6174. Do you have any doubts or questions?
Vagistan?
Yes, I have a doubt. So, not only like when you are doing numbers in ascending and descending order, even if you reverse it, I actually obtained 4716, which is the reverse of 6174, and I was again trying this. I reversed of any 4-digit number, and then 6174 appeared.
Wow, that's nice.
That's all.
Okay.
So, like, is it like this that the bigger the 4-digit number, the more steps we need for the answer? Because in this, for 9352, we needed 5 steps, and for the earlier number, which was smaller than 9352, we needed 4 steps. So, is there such a rule like that?
You can try it. So if we take 9876, there will be 4 steps because the earlier number was just the jumbled version of this. Okay. So should we move on? No more doubts?
Yes, we can move on.
Okay. So let's see another numbers. So what do you think there is special in 2025? You can raise your hand. Okay.
Vihan?
Yes, then I think I know. Just a minute. Yes. Oh, the number 2025 is divisible by 7, 12, and 30. You may see that they are ordinary numbers, but they are not. 7 is number of days in a week, 12 is number of months in a year, and 30 is number of days in a month. And that's what's special in it, I think.
Okay. No one else? That was very nice, Vihan.
Anyone else? Okay, someone said in chat 45 square.
Yes, 2025 is 45 square. Very nice. Okay, so one more interesting thing. If we cut 2025 in two parts, so we get 20 and 25. And then if we add them up, if we join them, we get 45. And 2025 is 45 square. Isn't that nice? Let's see another number like that. 81 is square of 9. And if we cut it in two parts, and if we join them, 8 plus 1 is 9 again. Wow. So these numbers are called Zarasandh numbers. So there is a story in Mahabharata that Zarasandh is the king of Magad, was the king of Magad, and if we would cut him in two parts, and then he would just join back again. He had a blessing like that. Do you think these numbers also have a blessing like that? And 9 is called as Kaprekar number or 45 because 9 square of 9 is 81 and 8 plus 1 is 9. So 9 is a Kaprekar number and 81 is a Zarasandh number. And one more interesting thing about Kaprekar numbers. So 3025 is a Zarasandh number, while 55 is a Kaprekar number. And 55, 55 and 20 plus 25 is 45. And 55 and 45 are complements of each other. A complement is basically like numbers who add up to base numbers. And base numbers are 10, 100, 1000, and so on. So it's basically 10 raised to n. So 55 plus 45 is 100. So this is very interesting. And some more Zarasandh numbers and Kaprekar numbers. 8, 2, 0, 9 is a Zarasandh number, which is 297 square. And 494 209 is 703 square. So these are some Zarasandh and Kaprekar numbers. So do you have any doubts? Please raise your hand.
Yes, let's see. Kashyap. Kashyap, can you unmute?
Yeah. So in this example, 88209 or any number which has an odd number of digits, how are you splitting it into two halves?
Like that, yeah. 88 and 209.
Is there a rule to split in that, or any two parts of it should be added to the sum? Or, I mean, can you split it into 880?
No, any two parts of it. Any two parts.
Okay.
No, 297.
Yeah.
All right, let's see. Once you're done with your question, you can please lower your hand. Mayuk? Okay, Mayuk lowered his hand.
Yes, can I didn't had any doubt. I just wanted to tell about 2520. Can I? 2520 is divisible by all numbers from 1 to 10.
Okay. Nice.
Okay. Thank you, Vihan. Joshua? Joshua, can you please unmute?
It doesn't allow me. So yeah, I just want to say something that if you take any series of nines and you square it, any series of nines will be a Jarasan number. You can break it down in the half and it will be a Jarasan number.
Okay. Is 729 a square? No, it's not, right?
It's a cube, right?
Yeah.
Then, like, I'm not like that. I'm saying like 99 square, 999 square, 99999 square, like that.
Okay, nice. Okay. That's a very nice observation.
Thank you, Joshua. Let's see, we have Kashyap.
No, I'm sorry, I forgot to lower the.
Yeah. Vedant?
I think there is a rule to split the two numbers as 88209. If we split it 8 and 8209, then there will be no there not the answer will there will be not the correct answer.
Yeah, but in this case, we have to split it like that. 88 and 209.
Then
in another case, we might have to split it in another way.
Then what's the rule to split?
Yeah, as she told the story of Jarasan, we used to split Jarasan into equal parts, right? So we have to split the number into equal parts. But it is 209 was a special case wherein there were 5 digits, right? So we can split it in 2, 3 or 3, 2, whatever is comfortable. But others we have to split in half, middle way.
Yeah. Okay.
Okay, Vagisan.
Is there any formula to create a Kaprekar number? We know that any base number minus 1 is a Kaprekar number, and how to create a Kaprekar number?
You can try to find out.
Okay.
That was a nice question.
Mayuk? Mayuk?
My hand was again raised. I don't know why.
Okay. Saurish?
How to find these Jarasan numbers?
Okay, that's a nice question too. You can try it out.
Is there any pattern? Maybe you can try to list down all the Jarasan numbers and see if there's a pattern.
Yeah.
Okay. Kashyap, is that a doubt or did you forget to lower your hand?
No, I have a doubt. So you have
Okay.
at the start that the 16-digit card number is related to the 4-digit pin because of the Kaprekar number. Can you explain a little bit more on that?
I don't actually know about that.
Oh,
Okay. So no more doubts? Okay. Let's move on. And let's see now the numbers which Kaprekar invented and which are my favorite. Monkey numbers. So Kaprekar loved trekking, and then one day he went to trekking on Brahmagiri, and there were many monkeys there. And then Kaprekar observed that the baby monkey is always hugging the mother monkey. And then he thought of some numbers which are like these monkeys. So let's see these numbers. So 100 is a monkey number because 100 is 10 square and 10 comes in 100. Yeah, do you see that? And what do you think? Is there any pattern in them? And also 49 cube, the cube of 49 is 1, 1, 7, 6, 4, 9. And 1, 1, 7, 6, 4, 9 is a monkey number. And also 49 raised to 5 is 2, 8, 2, 4, 7, 5, 2, 4, 9. And again 49 is in there, is in this huge number. And all the odd powers of 49 are monkey numbers. Here are a few more monkey numbers. 107 raised to 4. Yes, which is 131 0 7 9 6 0. And here 107 is in the middle. So it's not like it should be on the left side or the right side. It can be anywhere. So, and yes, 36 is also a monkey number, which is 6 square. Yes, more monkey numbers are coming up. 625 is a monkey number. How is 2 a monkey number? Yeah, 32, right. 625 is a monkey number. 32 is a monkey numbers. Yes. All powers of 6. All powers of 5. Yes. Nice. And yes. Yeah. All powers of 10. Okay. So that's it for today. And thank you for joining.
Yes, wait. I think someone wants to ask some question.
Yes.
Yes.
Yes, Avnish. We cannot hear you. Can you put it in the chat?
Can you hear me now?
Yes.
Yes. So I just wanted to ask, is 100 a monkey number or 10?
No, 100 is a monkey number.
Okay, thank you.
Yeah.
Okay, just a second. Before everyone leaves, I just want to make one announcement. We have Mr. Prakash Patak with us. Is he still there in the session? Sai, can you check? Prakash, I want you to unmute.
Yes.
We are lucky enough to have him with you, but he is not connected with the audio, I guess.
Yes, yes, he connected right now.
Prakash uncle, can you please unmute?
I am not sure. I am asking him to unmute.
Yes. So till he is unmuting himself, I will like to introduce him. We are lucky. He is a relative of Mr. Kaprekar, and we came to know that just before the session. We are really lucky. I feel really very lucky that he has lived. He has stayed with Mr. Kaprekar. And I request Mr. Prakash Pathak to share his experiences or anything he just wants to share. We will be lucky to listen. Yes, Prakash ji, can you speak?
Not able to hear you.
Hello, can you hear me? I am Prakash Phatak.
Yes, yes, sir.
Good afternoon, everyone. I am a privileged person. Mr. D.R. Kaprekar happens to be my sort of a close relative. He is my own uncle. His wife and Kaprekar's wife are real sisters. Unfortunately, no one is now alive. Whenever Mr. Kaprekar used to visit Pune, that time he used to stay with me in Pune. That time I was studying engineering, and he was a very simple, down-to-earth man. If you don't know about his background, you will consider him a very, very ordinary person. He was Gandhian, very simple life. He will wear clothes which are not ironed. He will not carry a bag. He will carry all his belongings in a so-called we call gathode. He will take a square white cloth, dhoti, and tie whatever his material to be carried in that. He used to stay with me, and in our Wada, in our place, there were about 10, 12 children, aged from, say, you can say 6, 7 years until 18 years. He used to collect all these children, then take potato, onion, and whatever vegetables are available in the home and juggle them. And that is how he used to attract children. And then he used to explain us the mathematical magic tricks. Mr. Kaprekar, when I was in close contact with him from 1967 to 71, during my 4 years of engineering education in Pune, he used to visit Pune University that time. And though he was not a, you can say, double graduate or master's, he was recommended for a special University Grants Commission scholarship to carry on his research work. He is famous for his discoveries. One is called Kaprekar number, the other is called Kaprekar constant. Then there are one more discovery which he said self numbers or Deolali numbers. There is one number which is called Harshad number, and you can read his information in detail even on Wikipedia. His first time, I don't remember, but after 1975, maybe around 81 to 85, there was a one full page article about Dr. Kaprekar in the USA's Time magazine, which is a weekly magazine. I think is a rare occasion where we came to know that even we are his close relatives, but we did not realize his value in the world. His first time in 81, his paper was published in a Scientific American by a research scholar from Holland. And that is how the first time he was known to the international world. I miss him. Unfortunately, he had no issue also. And whatever books he published, they were by his own money and own expenditure. At the end, he had to sell everything, all his rights of books, and get a lump sum amount. And then he stayed with Barner School in Nasik Domboli, which is a residential school. There he said that allot me one room where he will stay. And as we know, he passed away in sometime in 1986. And I really do not know his exact date of death also. My uncle's brothers are also in Mumbai and Pune. And we all somehow lost contact with him because he was a very person who wanted to be away from other people except mathematics. He did not want to talk on any other topic. I had during my college days hobby of magic. I had taken magic as a hobby, and he taught me two things which I will never forget. If you are given a square or a cube of any number from 1 to 100, just looking at the number, one is able to do the square root and cube root of that number. That is the beauty of the numbers. So thanks for giving me opportunity to share my experience, personal experience with him. And I will also congratulate Swati because at the age of 9, she is conducting this session. God bless you, beta. Take care.
Thank you, sir.
Thank you. Thank you.
Thank you so much, sir. We are very honored to have you here today. Okay, we have a raised hand here.
Hello.
Yes, sir.
Yeah, hi Swati. Congratulations. Very many congratulations. At this age, you're conducting these sessions is very nice. And thank you, Prakash sir, for giving us insight of Mr. Kaprekar. Swati, I have one question to Vinay sir also. Like we have gone through this all Kaprekar number and constant, and it was very nice to know. I just want to know two things. Like, what is the real-time application for these numbers? And like Jerasan number, and for a few of the students also had this question that how to find these numbers, because there has to be some pattern where I can find these numbers, and it can be a real-time application for these numbers. If anybody can give me a highlight on that, that will be helpful.
I don't know actually.
Okay.
I actually don't know. But if someone in the class or the session can have found it out, then yes.
Yes, and even I remember Swasti was talking to Gurkhindikar sir, I think in the 1 year back, and then he mentioned that the phone numbers which Nokia uses, the actual phone numbers,
Right.
there they are using Kaprekar numbers. We before we could know that for the house, he had visited that Nokia factory, Gurkhindikar sir,
Your
but we
voice is breaking.
couldn't get how is it used actually. Can you stop your video? Is it audible now?
Yeah, it's audible now.
Yeah, so they are used, Kaprekar numbers are used to generate phone numbers in Nokia, but how, not sure.
Okay. Now, as Prakash has said, that is finding a square root and cube root. Yes, it's a very good Vedic method, and I agree to that. There are very good numbers in mathematics, which you can, tricks are there, which you can find it easily with the numbers.
Yeah.
So thank you very much for the session. I loved it.
Thank you so much, sir. Okay, Sai, over to you. We are sharing our email IDs. If you have any doubts or queries, you can email so that we have to stop this session on time. So you can email your queries or doubts or your feedbacks on the email shared. Sai, can you please do that? And just a concluding 2 minutes.
Yes. Thank you so much, Swasti, for this wonderful session. So for the conclusion, I would really like to thank Vinay sir. We feel very honored. Swasti feels very honored to get introduced by her own maths teacher in a maths session. Thank you very much, Vinay sir. Thank you very much, Prakash ji, for joining and sharing your experience with Kaprekar. We are very honored. We actually got to know about him and told him just about 5-10 minutes before the session, and even on such short notice you joined. So thank you very much. Thank you, Anjali ma'am, who is Swasti's science teacher, for joining as well. We are very honored to have you all here today. Thank you, everyone. So, if you have any doubts, you can stay back. Otherwise, I will
Did you share the email address? Sorry.
Yes, I'll do it right away. So if you have any queries, you can email Swasti in this email address. So yeah, if you have any doubts, you can stay back and raise your hand, or else we can stop here. Thank you, everyone, for joining. Okay, I can see a few raised hands. Bodhisattva.
Yeah, thank you so much. It was a very nice session, and I just want to congratulate each and every person organizing as well as presenting this session. But one thing, is it possible to listen to this recording afterwards?
We have recorded this session. Yeah, some of it got recorded on YouTube, not all of it. Most of it is on YouTube. The whole thing will be available after a 1-2 days.
Okay, so how can we listen to that? Because a number of my students and all, I would like to make them listen to this. It is so nicely handled and so beautifully presented. So just how do I get the link? Will you be sharing the link in mathematics raising?
You can email us. So in
The
on the
link,
given
sorry,
ID.
the link is just, I have just posted the link on chat. You can just maybe click that. That's the YouTube live link.
Okay.
So yeah, you can get
Yeah,
almost
it's
all
not.
of it.
Yeah.
Is it possible for anyone to post it in the RTM platform, raising the mathematician? Because we all are member of that.
I will do
So
that. I will do that.
thank you so much. Thank you so much. So that would be a nice thing. Most welcome. Thank you, sir. Okay, I'm dropping off. Thank you.
Thank you for joining.
Yeah. Bye.
Mayuk, you have a doubt?
I don't have a doubt. I was saying just to unmute me. And thank you for the session.
Thank you for joining, Mayuk. Thank you for your doubts. Hiren sir, do you want to say something?
No, my doubts are clear. Sorry, I forgot to lower my hand.
Yeah. Okay. All right. Thank you everyone for joining. Thank you once again. We can stop here.
Thanks. Bye.
Sahi, I think the YouTube streaming needs to be stopped.
Yes. I'll do it.